Let's say we wanted to add a specific number to all numbers between index A and index B. In this case, index A is at 2 and index B is at 6. And let's say that the number that we wanted to add was a 5. The naive solution is to simply loop through all elements from index A to index B and add 5 to them. This solution is fine if you only need to do this operation once or twice, as it has a relatively quick O(n) runtime. However, there exists a solution that can perform this operation in O(1) time. First, let's consider an array full of zeros. Let's say that we wanted to add 3 from indexes 1 to 5. And also, we wanted to add 7 from indexes 3 to 7. Instead of simply looping through 1 to 5 and adding 3, then looping from 3 to 7 and adding 7, we can instead add 3 to index 1, then subtract 3 at index 6, then add 7 to index 3, and finally subtract 7 at index 8. Once we've made all of our changes and we want to finally create the desired array, we simply loop through all elements, and for every element we will add the previous element to the current element. You could think of adding that 3 at index 1 as starting the addition operation, and then subtracting that 3 at index 6 as the end of the addition operation, which means that we don't want to add 3 at this element or at any elements past this one. Note that no matter how many elements we cover with an operation, or in other words, adding or subtracting from index A to B, it will only take 2 operations to perform, which is still O(1) time, ignoring the O(n) cost at the end. So for example, if we also had to add 14 to all of the numbers, we could instead add 14 to the start of the original array and then not subtract 14 to the end of the array to avoid an array out of bounds error. Let's return to our original array. How are we supposed to add 5 to the elements using the method that we just went over? If we were to add 5 at index 2, subtract 5 at index 7, then loop through the array, we wouldn't get the right answer. We need to first turn this array into a difference array. The first element of a difference array is the same as the first element of the original array. Every element after the first one in a difference array represents the difference between the current element and the previous element. Now that we have our difference array, we can simply add 5 to index 2, then subtract 5 from index 7. And then we process our array by looping through the array and adding the previous element of the current element. And that leaves us with our final answer. So in general, the difference array is useful as it allows us to add or subtract a number from a specific index to another specific index in O(1) time, and then only require a single O(n) processing time at the end. To make a difference array, loop through all elements. Let the ith element of your difference array be the current element of the original array minus the previous element of the original array. To add or subtract a number, x, from the 8th element to the bth element, add x to the difference array's 8th element, then subtract x to the element 1 after the difference array's bth element, in other words, b plus 1. That'll be it. Thanks for watching.